Hi, my name is Alexander and we'll be doing chapter 6. A random variable takes numerical values that describes the outcome of some chance process, and a probability distribution gives the possible values and their corresponding probabilities of a random variable. Two types of random variables. A discrete random variable is one where it is possible to assign a probability to each individual outcome and then add up all the possibilities. What this means is that there are a finite number of outcomes and the probability for each outcome is between 0 and 1, and the sum of the probabilities for all events is 1. An example of this would be rolling a perfect six-sided die. There are 6 outcomes, each with a probability of 1/6. The sum of all probabilities is 1, and each probability is between 0 and 1. The second type of random variable is a continuous random variable. A continuous random variable x takes all values in an interval of numbers. What this means is that in the interval there are an infinite number of values that x could take. Probability distribution for x is described by a density curve. The probability of any event in the area under the density curve and above the values of x that make up the event. An example would be the heights of people in a population. There are an infinite number of possible values of a person's height in a population.
When we multiply or divide a random variable by a value x, measures of location and measures of spread will be multiplied and divided by x, but the shape of the distribution will not change. And if you add or subtract by a value x, measures of location will have x added or subtracted, but values of spread and the shape of the distribution will not change. All of these are considered linear transformations. To find the mean of the sum of two random variables, x and y, you simply have to add the mean of x plus the mean of y. The same principle applies to subtraction. And if we have two independent random variables, x and y, and z is defined as x plus y or x minus y, then the square of the standard deviation of z is equal to the sum of the squares of the standard deviation of x and y. A common mistake is to simply add the standard deviations, but you really have to add the variances. And also, you can't find the standard deviation if the two random variables are not independent of each other.
Binomial setting arises when we perform a series of independent trials of the same chance process and record the number of successes for a particular outcome. There are several conditions that we have to check in order to use a binomial setting. B is for binary. The possible outcomes must be classified as a success or failure. For example, if we're flipping a coin and let's say we're checking for heads, then there's a distinct success or failure. I is for independent. That means that the results of one trial can't tell us about the results of another trial. N is for number. The number of trials must be fixed in advance, whether that be 1 trial, 10 trials, or 100 trials. S is for success. There must be the same probability of success for each trial. If you're flipping a coin, each time the probability of getting heads is 1/2, so that doesn't change, so the S condition is met. In order to calculate the binomial probability, we need to calculate the binomial coefficient, which is n choose k, which is equal to n factorial divided by k factorial times n minus k factorial. The binomial probability formula, given that we're conducting n trials and the k number of successes with a probability of success of p, is n choose k times p to the power of k times 1 minus p to the power of n minus k. Sometimes, if we're conducting an SRS, we will need to check the 10% condition in order to approximate independence. In addition, we may need to check the large counts condition in order to approximate normality. The mean of a binomial probability distribution is equal to n times p, and the standard deviation of a binomial variable x is equal to the square root of n times p times 1 minus p.
A geometric setting arises when we perform independent trials of the same chance process and record the number of trials it takes to get one success. On each trial, the probability of p successes must be the same.
Now we'll be going over how to calculate the binomial coefficient on a calculator. So in order to calculate the binomial coefficient for the TI-84, first let's say you're conducting 10 trials and you're trying to find the probability of 4 successes. So first type in 10, then press math, then go to the probability section, then go to NCR, which is 3, and then press 4. And then once you press enter, then you should get the value 210, and that is your binomial coefficient. In order to find the binomial probability on a calculator, you need to know the number of trials n, the probability of success p, and the value of interest for the variable x. Let's say that n equals 10, p equals 0.4, and you want to find the probability that there are exactly 5 successes, so k equals 5. Press second, then vars, and then press alpha, then press math, and that should take you to binom CDF. And we said 10 trials, the probability is equal to 0.4, and the x value equals 5. Then just go down, press paste, click enter, and that should give you the value 0.200658. If you want to find the probability that there are 5 or less successes, we will use the binom CDF command. For that, you press second, then vars to take you to the same distribution menu, then press alpha, then press B, and let's hold the same number of trials and probability and number of successes. So 10 trials, the probability of success of 0.4 and the x value of 5. And then press paste, and then once we do that, we press enter, and we get the 0.83376. So as you can see, when we use binom CDF, the probability is even greater because it includes all the values from 5 and lower.
This is question number 3 from the 2015 AP Stats test. It reads, a shopping mall has 3 ATMs. Let the random variable x represent the number of ATMs that are working when the mall opens on a randomly selected day. This table shows the probability distribution of x. So the question asks, what is the expected number of ATMs that are working when the mall opens? So we learned previously that the mean of a discrete random variable is the sum of the value of each event times the probability of each event. And from the table we get those values. It's 0 times 0.15 times 1 times 0.21 and so on. And we add them all up and we get 1.73 is the expected number of ATMs that are working when the mall opens.